So, rotate something.
Yeah, some rotate.
The camera rotated a little bit, maybe?
Oh, that's probably what it is.
Cameras.
Like, yeah. Because there's no way that that's square. That's square like that. Let's super sandy check. Let's say signals next wall. It's perfectly orthogonal. I don't think it is. I'm not too far away to do this. Alright. Maybe is this one? It looks like it's on there. It's pretty bang on square. The microscope might just be slightly not exact. But yeah, so basically where those are, that's where you would land the 3 pins of the probe, right? So if we
So it has 3 pins.
sorry?
It has 3 pins on the probe.
Yeah, so what we'll do is here, I'll just show you what the probe looks like. We won't actually we won't probe onto anything. Just for the sake of not damaging.
Yeah.
Oh wait, we gotta do this.
Yeah, one point about the landing the probes, I think there's
Yeah, we're not gonna land
usually
it.
like a lot less scrub. Like when we saw the needle and moving the needle,
Yeah.
and with our probe, it's just a little bit. You know, you're not gonna move it very much at all.
It
Not
will
high
be
magnification.
damage.
Very, very light.
Yeah, so there's what the probe looks like. That's it.
Oh, okay, so it's 2 lines.
So there's 3. See how there's 3? So this is your ground, your signal in the middle. And then when we but if you go back to the substrate, see how there's there basically be
Yeah, in middle.
the ground, the signal, the ground, and then yeah, basically these are all similar ones too. I think it tells you which ones are open, shorts, and loads, right?
And we did a similar adjustment, like touching the probe.
Yeah. So basically, these would be your shorts. Yeah, they're straight through, right? So that would be your short, and then I'm assuming this would be your open. And one of these is a load, and then there's usually like a section here. Down here for cleaning. What's the proper term? I was gonna say cleaning your probe tips, but that's probably not the
Which part?
down here.
Oh, that's for.
Is that for checking for planarity, or is that more for?
TRL.
That's for TRL?
Yeah, I believe so. There's different.
Oh,
lengths.
I thought one of them was actually for cleaning the probe tip before you touch down the cal substrate.
There might be, but I'm pretty sure that's not it. It's like you should see like left to right. I think different lengths of that same kind of structure. I believe. So
Oh
I'm
yeah,
sure
you're right. Yeah, so that would probably for TRL.
So, I don't know what it is about the cow with something certain distance. I don't know. They figure out.
Well, I think they take the difference, right? If they don't need to know the absolute number, but if you essentially you're subtracting one from the other,
Oh,
right?
okay.
To do a relative measurement.
Right, yeah.
I think that's the R, is relative something relative length. The difference between the relative length or
It's like
something like
500
that.
microns, like this, 1,000 microns, like that. Yeah.
Go ahead and try to lift it.
Because on your subdivision, we should have 2 more probes. We're making it just on the ground.
So far we got 4 RF probes, right?
Yes, you have 4 on the station and 4 on that station.
Oh, we can use those here as well.
You can. He's probably thinking if you really want to use the probe stations fully, then you probably want 2 more for this one, so that if somebody's doing 4-port RF measurements, they can also have 2 DC probes to provide power to the chip that they're testing. So yeah, we were kind of short on cash, right? So
He was also, I mean now, apparently it's $2,000 each to set it. So we have some maybe money for accessories and good to outfit to say these things. But also, do you have like he's stuck on this one single
The chuck.
chuck? So maybe can you not have like a disc with no hole with one line in the middle, put on top, and then
Yeah, I think
there's an adapter kind of thing?
there's no adapter per se. Like I know what he's saying. Like we'll bring it back to MPI and say, hey, what would be a good solution for something
But if
like
they
that?
make another disc chuck like that with one hole, and you could put it on top of it.
Yeah, no. So there's two things. One is if it was just one hole, would it be strong enough to hold? So that's the first question. Because if it is strong enough, then we literally could cut you a piece of metal and put one little hole in the middle that was just slightly bigger than one of those holes, and you could just move it around where you wanted to. That would be solution number one. Solution number two would be, like Brian was saying, if for some reason one hole is not strong enough, because it's a small hole, right? Like you can only get so much vacuum power out of these little tiny holes. If it's not strong enough, then maybe you build something that would almost, in a sense, look like this, right? And if you actually,
Exactly like
you could actually just use, you almost could use, if it was really flat there, you could just drill a little tiny hole and just use that, and that would actually solve the problem. Actually, yeah, this
No,
is
he did use
This
the
is-
EMS.
really close to what it made me,
Yeah, exactly.
right? If only it was a little bit flatter. Wait. Use this thing. Yeah, you could use this. You could literally drill a tiny hole in here. Actually, as long as the hole was less than 1 millimeter and your die would sit on it without falling through, this would actually do the job.
Yeah.
Right?
The other thing he told me is that one thing that he's thinking that things would work and the code that are moving with the code. And he's worried that that's going to be the first thing that's going to break. He said that you heard about it. Right?
Just talking about to better practice if you do us fixed with the fixed portion of this instead of this moving portion.
So
He's worried that these are the first thing that he hears. Do you see this failure or what?
I can't, like the fact that it all depends, because if students are not nice to equipment, then yeah, it's gonna fall apart sooner. If they're good to it, it'll last longer, right? The way that this is gonna be set up, I don't see them moving those things that often, because basically this probe doesn't go at this station. It could, but it doesn't. We basically, for this station, we have these little supports here where you can connect your cable up to it, and it'll hold the cable there so that it doesn't move and flex.
Okay.
Right? So that basically, when you're connecting this up to your DNA, you're not getting any movement on this side, right? So what Amir was saying is, hey, this piece should be attached over here as opposed to here. But honestly, like the best solution would probably be attachment here and attach another one here.
Right.
Because if you put it here, the fact that this moves and this doesn't move, that means the cable will actually move more. We put it here so that the whole thing moves together, and because when you're making really high frequency measurements, this moving actually could change the measurement. That's why we attach it to the part that actually moves up.
And especially for RF, right?
Yeah, RF and millimeter wave work. Like I would say if you had levels of good, the worst is, I guess, nothing attached. Second best would be one attached here. Third best would be one attached here, and I guess the uber ultimate one would be attached here and attached here, so that then you relay it. But honestly, I don't see how, like, this option versus one attached here, it's not that much better. Like I don't
But
see.
here, there's not attached.
Nothing's attached, but this one, so what happens is this cable here actually attaches to the, there's a connector, there's a panel, right? So when it's attached to the panel, now you're not really getting, if somebody's not going to move that cable. Like the problem that people are thinking is if it's attached to an instrument, if somebody is touching the instrument or something over here, it's going to move over here. But since it's going to a panel, and the panel's going to the probe, then you're not really going to get that issue. Like this part is a lot lower cost to replace this section here than than the positioner itself for the probe wire. So it's I don't think it'll be. Triax cables they typically are more. Actually, Brian, you would say triax cables are probably more robust than RF cables. Is that a fair statement?
I can't speak intelligently to that. I don't know. As far as like integrity or strength or
Extension.
take them swimming with it, I really don't know.
Okay.
Well, I'm saying it's like you're supposed to put the 200 to 1015, so you cut the board over there. But you don't really see that they have still the the carrier and wheel taking yourself, so we don't need that. White boards,
So that should be 0.
Specs?
Yes, this is according to the specs. It can fix with this cable, so you don't need to take it off. The small one,
Connection copy.
will be okay.
I don't know. They're gonna like edit the video.
It's still not on the table.
But let's see how it goes.
Okay.
Everyone's like, let's take
So I was honestly you guys were talking.
Which your question?
So regarding the RF flow, we the similar procedure that we did for the display, right? On the touch the surface of the probes on the IC, right?
You want to actually
I mean,
do it?
we do the similar, like what we did.
Oh
for the
yeah. So the only difference, like Brian was saying, is there's not like this. If you look how long this tip is, right?
Yeah.
When you put force against it, it'll move a lot
Little bit
more.
more, yeah.
This one's so short, it's only like here, so you're not going to see a lot of escape. Like you got to be really vigilant on it and careful.
But can we we have ICs? Can we just do a little trial, because we will be using these if the student comes. So
Okay.
right.
I'll Brian do this
It's
one.
better to practice.
Well, there's that, and when you look, remember when we looked at the probe, there's 3 probe tips too, right? So this is where the planarity actually matters quite a bit to make sure that we don't want to land the probe like this.
Mhm.
We want to land it as close as possible, flat, right?
Did somebody scratch the?
Where?
Tweezers. Danger.
Wait.
This must be a rain.
Oh, there it's a scratch. I'm like, where are you seeing the scratch? I don't see it.
You don't see?
I see it now.
Look at it this right. Yeah, tweezers or something, anything metal can really see. And even though they have like plastic tip or like a soft tip type tweezer, if you're doing a lot of small die like that, you may want to get something like that, because these are probably not very good if you're going to be working. Yeah, it's okay if you want to use those for a probe needle, putting a needle on an arm or something like that. But a substrate, I know they have like soft tip type of tweezers that probably be better for that.
But this won't scratches won't mess up.
It
the-
won't affect unless
Yeah,
they're
right?
deep.
They have to be really
Pretty deep scratches to
yeah.
make.
You don't want to make a habit of it for sure. And this surface here too, this is an air bearing surface here. It's very careful not to it's an easy surface to put tools on. Yeah, it looks like a place to put tools, but you want to keep that very clean and nick free as well. Yeah.
What are you guys looking there?
That's the cal
So we're just
substrate.
trying to put this probe on the. This is the calibration substrate, right? This is calibration substrate.
So
But we can use any
that's
ICs
so that's the tip of the probe,
for this
So it's-
for RF probe.
and then so we can focus on the cal. So basically, you see how there's 3 lines here, Julia? Right? See how there's 3 sections to that?
Can we
So-
go more closer, to see how close before touching?
Those would be the 3 spots that you'd want to connect up to that point. All right. So sorry, you wanted to actually
Almost touching. If you want
yeah
to exactly
go,
use.
go for it. I'll because I think at this point we can make it go down. We have I think we have enough travel to get to where we need to.
So we have to go the Z, right?
Yeah. It's
down.
pretty far actually. I don't know. We might make it. We might not. We might have to raise the platinum.
Just say go, go, go.
Actually, you know what? Hold on one second. We'll raise
There's a lot.
Yeah, we'll raise this up. Alright, so that's the size of that purchase. Okay.
The highest. Okay.
Yeah, you should be able to go down. Should hit it.
It can go that much.
It'll be pretty close. You should have about a.
You can't lift the bar as well, or you try that.
I think that's the highest. Yeah, I think it can go 3 millimeters.
Oh, you know what we can do? Oh, yeah, keep going. You can actually adjust where this goes. Like this is locked in now, but you can actually unlock it so you can raise it up in it. But I wouldn't okay. It's not. It'll loosen. You can either tighten or loosen it. But actually, that one's actually at the bottom already. So that's.
Where's the long?
Let's see if we can get there. I don't know. You might not be able to.
Yeah.
You're coming, so I could see if
No.
they're clear the tip.
No, it is highest.
Oh, you know what? I did the. Oh. All right. No, you can put it back in. Yeah, just put it back in and screw it the other direction where you.
Other way, right?
The other direction of where you're. Just make sure if you don't cross it. Yeah. Sorry. You know what? This is up the highest. We should move it down the lowest.
Yeah, that's how I'm talking about.
I'm like, whoops. All right. I'll do it slowly as you raise it up. I'll raise it up too.
I'm raising up because we should have some,
Yeah. I was like, wait a second, I think we're doing it the wrong. So you can keep going if you want. Oh, wait. Okay, we'll get closer. Make sure we don't. I just gotta make sure.
Yeah, it's going down. Yeah.
So if you want, raise it up a
Something
little,
is moving,
raise it up
right?
a little bit more.
Why is whole thing moving? Yeah, it's like a hair.
It's like shocks in your car.
Okay.
No, it actually is pretty close to that.
So it's just pneumatic or something.
Yeah. All right. So that's why we're playing good. Now you actually should be able to get there.
So there is no sensor. For example, we have wire bonder. So we're going to bond.
Mhm.
It detects each has a sensor. So it detects the height. So once we touch the different height, it go back.
No. Yeah, this
This
isn't.
is a manual code. Right?
Hey, there you go. You remember.
So go down.
Yeah. So you go down, and you can see on the probe station. If you look at the screen, you can almost start seeing. Yeah. So I won't go too far down.
Because we also have the shadow to meet each other,
Yeah.
right?
So this is where you'd probably want to start, tweaking. These things and kind of get
So to see the shadow maybe.
Yeah. You can. You're good. You're still pretty far, but
Yeah, I see a lot of space. It might be alright.
maybe we do need to move it a little higher. You think you'll get there?
It almost is closer, right?
Yeah.
Raise your program down?
Is my what?
Program? Or the platinum, excuse me.
Yeah.
Oh, okay. Then the platinum itself can go. You have that
Yeah, it's not quite all the way, but it's pretty far.
Yeah, it's still. I mean, we can go more, right?
Yeah, 'cause
Yeah, you could probably.
Once we want to work.
That's
Where are you
pretty good, right?
you're getting there.
Yeah, you can.
Not bad.
All right, go ahead. Might as well.
How about it?
Go down. Go
A
down.
little bit, right?
Don't worry, there's like 50 points. 50, 50 sides. You don't get the screen.
And then when you touch, you want to look to see if like one side moves before the other.
Yeah,
See
that's
if
what
you-
you're really looking for.
See if your probe is plain or.
Because for the DC probe, I'm sure that the shadow is coming and meeting each other. That means they're coming closer. But here, can we expect that same thing, or
It's harder, right? Because there's not. You don't really have.
we don't expect the shadow?
You can. You should see because it's thicker. You might not see it, but you can keep going. You're still a little bit away.
Why are you worried about touching?
Because
Well, you don't want to crash. Touching is okay. It's like landing. You don't want to crash.
Do you see that you're touching?
You'll see it move. Oh.
Yeah, it's now touching, right? Or no?
You'll see it move. Let's see.
go more.
Did you make it touch?
We have magnifying glass. You can see that from the
We
side.
we have
From
external, but they should have some like built-in shades.
Brian, how can you tell if we're touching with your arm? It's pretty tight.
It will skate.
All right. Oh no,
No, just not as much as a DC probe. You will see
Did
it
you
move.
see that? Did you see it skate? Did you see it move? Did you see it move laterally?
Yes.
Well, he moved
yes.
he moved this though.
Yeah, that's why maybe.
Okay.
If you're not sure, you think maybe
Go up a little bit, right?
the safest, yeah, go up. You can even lift the platen lever just up a little bit. And I think it did touch, yeah.
Yeah.
Yeah, just pick it up just a little bit.
Oh, let's tell you. I don't know.
Oh, and then if you're up at the 300
Oh, we're already
micron,
down all the way, but do you want me to go up?
yeah, you go up just to the first indent, so 300, and then you can just move the stage over a little bit. See if and you'll see some marks if you did hit. Nope,
Didn't touch.
All right.
that's gold. It'll show a mark. So then you can platen lever back down, and then maybe a little bit.
All right. Go ahead. A little more.
With this close position or open position?
Down. You want if you're gonna touch down, you want it all the way down.
Yeah.
You
Yeah.
know, once you're happy with it, you can lift it up so you can move to like another calcite or something.
Yeah.
Or
Probe down arm, or probes down, probe tips down, platen arm down.
always, yeah.
Yeah, platen arm has to be down.
Anything logically, you can't crash anything if it's already down. You can
Yeah.
like lift things up. If everything is up and you're like, oh, did I push that down? And you push it down, and it's like,
Yeah, that's really good.
all right,
Make sure you
go ahead,
brush
move it. I want to
Yes.
see it.
So you
Or
should
close.
brush it so that you know
Go down.
Yeah, go down a little bit. Oh yeah, we're good. You're good. That's it.
how do you know.
Did you see it move? It moved this way. Did you see it move?
I
Yeah.
saw.
I saw
see
that.
how it moved
yeah.
right this way?
Like this.
So that means if you look, you're looking at it like this, and you're basically seeing this.
Oh, okay. Sliding.
Yeah. So that's it. So what we can do is see we can lift it up if you want to see. And they actually touch down pretty close.
Yeah, that's marked. Yeah. Now it's marked.
Yes.
Yeah.
There you go.
Okay.
So what is that bad?
That's good.
It's
No,
good.
you want to scratch because basically that's how you get a good connection.
Yes.
You just don't want to like scrape across the whole thing, but you want a little bit of because you're basically scratching off the oxide that builds up on top, so you get a good connection.
So now what do you do? You
Well, now we don't have an
connect
instrument
This,
connected,
this,
but
that's the,
this-
now
this
it
is-
goes. Okay, now it goes to the
yeah, this is where you would connect it to your VNA, and
VNA or
your
PNA
VNA would
for giving
say
signals.
connect your
Our
open,
signal, yeah.
right? You'd be like yes, connect your short, connect your load, and obviously you'd have to have the matching probe on the other side touching down on the same thing, right? You want it from well, for certain ones for through. Yeah.
You can also check and see if the marks are even. If
Oh
your probe is planar, like lift it up to that 300 again, and then
So we
scoot
can
it
do that.
over and see if you got good marks.
So let's try that. So
So if your probe is planar, then the marks will be even. You can even zoom right in on them,
No, they're not even.
and the marks should be pretty much the same size.
Oh, they're
Pretty
pretty
good.
good.
Good job.
Very nice. Look at that.
ah,
And if
look
they,
at you.
yeah,
Oh,
and,
you're
and if they weren't, you'd see like one would be fat, and then maybe medium, and then skinny. You know, if it was doing this, where one is
Right.
going down more than the other.
How do you keep
Yeah,
that
it's really
very
good.
flat? There's no suction?
There's section on the cal substrate, so.
And if you did have to adjust, there's a thumb
Oh
screw
yeah,
right there,
there's
and that will adjust the planarity of the probe if you need to.
I guess we can.
Yeah. There's the brightness.
The thing is, the camera itself adjusts, right?
It does, yeah. The digital camera, you turn up the light, and
Mostly adjust that.
there are some settings with the mouse. You should be able to play with the contrast.
Yeah, it's almost.
Somewhere in there, maybe. Or maybe the monitor itself.
Can you guys smell anything?
Sorry,
Are you smelling anything?
are we?
Smelling? Smell?
Smell?
Yeah.
Oh, smelling?
Yeah.
Oh.
There's something. Anything burning?
I think so.
No.
The vacuum pump might be getting warm.
Mm-hmm.
But no, that's good.
Yeah.
Well, if you think about it, the station is kind of set up to be very, very planar, I guess, right? Everything should be planarized to everything else. So you hopefully shouldn't have to adjust things. If you had to adjust things, that probably means that something else was out a little bit.
It should have 2 days, actually 2 days training, 1 day for this, 1 day for that.
Yeah.
Oh, I mean, nobody's there who are continuing this. It's 5 o'clock.
I think, can you guys come another time for this?
Well, Brian probably can't because he's actually coming out here from Vermont. We'll figure out something. Gotta get Tyler up here at some point.
Yeah. What a guy is actually looking for, what do you think you need? Just more time on the station?
I think, yeah, they all,
Using it?
exactly.
Going over everything and stuff. I mean, yeah, because if you guys aren't comfortable, we haven't even touched this one yet.
Yes.
You know, I mean, if you guys aren't comfortable, you probably should
Pretty
come back tomorrow.
It's something to do with that.
I'm talking to you.
He's gonna take me out to dinner and unwind and dine and try to talk me into that. But no, we should. Because I don't want to rush through it and make you feel like you're not comfortable with it. You know, it took a little longer, you know, with the training than I thought it would. So
Yeah, also
it makes sense, you know. And then, to come back, you know, maybe do another session. 10 o'clock tomorrow.
I don't think it will take that much time like this because it was the initial one. Now we know.
Oh, so, okay, yeah, I guess if you're, if you can come back, that'd be, since you're already up here.
Yeah. We are working since
I didn't
9.
realize that.
Right? Without any interrupt. Yeah, only the last
Just the
hour.
last break.
Yeah, but yeah. But I mean, it's more important, you know, that you guys are comfortable. I think you're a little bit comfortable with that one, but we'll spend a little bit more time on it.
And you want
We
to
haven't
try
spent
the
any time on this
too,
one,
right?
so that's important.
The one I had one, but I'm not sure if it's easier to. I mean, it's safe to practice with that with RF probes.
Maybe like tomorrow morning until Brian comes, you could
We can try our
Try
maybe a couple
and
of with the DC
Yeah, for
probes.
sure.
We can try fixing.
Well, what is your chips like? What do you is it an RF board or a chip or is it DC? Like when I say DC, it's that could be up to like 500 megahertz or hundreds of
So the
megahertz.
regular one, the one we are doing practice, also bring a couple of more.
Okay.
So probably we can do a little trial with that one as well.
Okay. What frequency range is that chip?
After that I don't know, maybe.
Is it DC?
Yeah, it's DC.
Yeah. Okay. Then that shouldn't be.
We're not going to connect with the signals and anything. We're just positioning.
Oh, you just want to. Okay, yeah. If you just want to actually, well, you could do it. Like if you're gonna practice, I would say use the DC probes. If you actually want to take measurements and you have an RF chip,
So we have to wait.
then you could, like Brian's here, we could do it. You basically need to hook up your other instrument though, right? Like, do you have a VNA you wanna? You said you have a PNA, right? You guys, I think you bought a PNA. PNA X or just a PNA?
Yes.
Okay.
I know the name. I don't know
There
what
you
the hell
go.
it does, but I know how to figure out.
I guess we will have separate training on PNA as well.
Yeah. What frequency range did you get?
Till 14 giga.
14 years. Okay. Okay, so it didn't break the bank then.
It was, no, not.
Because you could buy like a 67 gigahertz PNAX. That would
I
be
think
like.
it was gonna be Infineon, was the PNA was Infineon?
Infineon.
If it was 4-port,
No, that's,
this is.
what was the PNA before we were thinking of that?
Oh yeah, I didn't know how long you were staying for, but Were you staying tonight anyways?
Yeah, no,
Well,
just for the.
Oh,
Yeah,
no.
I'm saying tonight,
Okay.
yeah, I was planning on driving back first thing in the morning, that's what I was going for. But at the same time, I thought we were gonna get.
Everything's set up.
Cardboard.
Oh.
So that kind of hurt things. But now what we can do, let's come back, like 9 o'clock, if I can stay here and finish this one up.
Yeah,
I don't know
all
if we
set
gotta-
up.
Yeah, I don't know if we're gonna close up the lab or anything like that, we're gonna finish setting this up. And then
I think you're almost done.
Yeah.
Besides the micro, like the pro positions themselves, the thing I could do, unbox anything. Really good at unboxing.
That's
You like no?
unboxing. Special talent areas.
Yeah.